Welcome everybody to our Veolia Water Tech Talk today on Precoat Filtration 101. We've got about, I'm going to give it about another minute or so. I can see that we've got some people hanging out in the waiting room trying to log on. So appreciate your patience and we'll get started here in about 1 minute. Thanks. Okay, welcome everybody to our webinar today. My name is Jill Browning and I'll be the moderator for today's webinar on Precoat Filtration 101. Before we get into our presentation today, I do have just a couple quick housekeeping slides to go over. First of all, hopefully you should be able to hear me speak at the moment, but I do want to just make note or mention that there are two different ways to connect to the audio should you have any difficulties throughout the webinar today. You can connect either through your computer or calling in direct through a phone line. And also, due to the large number of attendees that we have on today's presentation, we have gone ahead and muted everybody's lines. But no worries, you still can interact with our speakers today. And in terms of doing so, you can ask your questions through the questions panel, typing those in throughout any time throughout the webinar today. And at the end of today's presentation, we do have some time set aside for a Q&A session. So please feel free to ask any questions that may come to mind throughout the webinar, and we will try to get through as many of those questions as time allows at the end of the presentation today. Today's webinar is one of many in our upcoming Veolia Water Tech Talks program that is happening throughout this year. If you're interested in signing up for any of the additional webinars or future webinars, please feel free to check those out over at www.veoliawatertech.com. And on the screen here, you can see some of the upcoming ones that we have throughout the rest of March and going into the beginning of April. In addition to the live webinar series, we have gone ahead and made available our collection of on-demand webinars that we've conducted over the last few years. You can access those on-demand webinars, again, over at that www.veoliawatertech.com site. So feel free to check out those on-demand webinars and sign up and register to watch any of those that may be of interest to you and watch those at your convenience. Another quick housekeeping note here, I just want to make note that a PDF participation certificate will be made available to you at the conclusion of the webinar. You should receive that within about 24 hours or so, so be on the lookout for that in your emails tomorrow if that is something of interest for you. And then also just wanted to make a quick note that at the end of today's webinar, you will receive a quick survey requesting your feedback. It should take no more than 20 to 30 seconds of your time. And for those of you who do complete that survey, you'll be entered into a drawing for a chance to win a $25 Amazon gift card. So please feel free to take that, and we do highly value any and all feedback that you provide. And if you are the lucky winner of that $25 Amazon gift card, we will follow up directly with you at the conclusion of today's webinar. Now, before we hop into the main part of our presentation today, if you are not familiar with Veolia Water Technologies, we are a leading water and wastewater technology provider, and we focus our efforts within three key main areas. First being technologies, we offer advanced and robust water treatment technologies and have a large portfolio of over 350 proprietary technologies that we offer to our clients. In addition to our technologies, we are able to pair those technologies in terms of developing projects for our customers, as well as put together multiple technologies to meet required treatment specifications for our clients. And then lastly, we've got a very thorough service offering that we can provide, whether it's during a project or through aftermarket sales at the end. And then in terms of supporting, we support our clients through a variety of different markets. You can see a few of those industrial markets listed on the screen, as well as working with municipalities as well to help support their water and wastewater treatment needs. So feel free to check us out over on the website again, that www.veoliawatertech.com, if you're interested in learning more about our capabilities there. Okay, so now I'd like to introduce our speaker for today's presentation. Kim Fernandez is a process engineer at Veolia Water Technologies. Kim graduated with a BS in chemical engineering from Texas A&M University and has worked as a process engineer at a petrochemical plant for over 7 years before joining Veolia. So with that, I would like to now turn it over to Kim to talk with us a little bit more about Precoat Filtration. Welcome, Kim.
Thanks, Jill. Hello, everyone. Today, we're going to look at Veolia's Precoat filters. So for this, we're going to first start with the filtration spectrum. Then we're going to look at what Precoat filters are. We're going to look at the different types and configurations of Precoat filters and how they work. And at the end, we'll look through some of the applications and some case studies. So first, let's take a look at the filtration spectrum. So in this chart, you can see the size of some of the common materials that we know. And their sizes are put in micrometers, or more commonly known as microns. And also shown here is the various processes that are used for separating them. The Precoat filters and particle filtration are focused on removing particles that are above the 1 micron. So that's what we're going to be focused on today. So let's take a look at what Precoat filtration is. So Precoat filtration is a solid liquid separation process that uses a filter element that throughout this presentation we're going to be referring to as leaves. So here you can see a leaf cutaway that we have. And the Precoat is a layer of material that is deposited on this filter element. This layer, also known as filter aid, can be diatomaceous earth, cellulose, perlite, or even solids in the field. You can see here, this is the filter element, and this is the Precoat layer. And the pre-coating, as you see, can allow for a finer filtration that would otherwise not be possible with just the filter element. And typically, we look for about a 1/8 inch of Precoat layer on the leaf, and this is usually achieved by putting in about 0.1 to about 0.2 pounds of Precoat per about per square feet of the filtration area of the filter. During service, sometimes you can also add a continuous stream of filter aid to the feed, and this is known as body feed, and this is usually added to keep the filter cake permeable and to have a longer runtime. Typically, if you do need to add body feed, we'll add it in a 1-to-1 ratio to start with, which is 1 ppm body feed to 1 ppm solids in the solution. So this is a microscopic view of the 3 filter aids, the diatomaceous earth, or known as DE, perlite, and cellulose. DE is made of amorphous silica and is mined from various deposits, crushed, and then heated to create an inert filter aid that is powdery, but is robust and porous. Perlite, on the other hand, is mined from volcanic rocks, crushed and then expanded, which creates these small openings in them, which gives it its porosity. Cellulose is plant fiber, mostly made from wood pulp and shavings. And the small fiber size means there's a lot of void space in between, which again makes it a great filter aid. From all these three, you can see that these make great filter aids because they're all porous and have openings in them that allow the liquid to pass through while filtering out the solids. Now, the selection of the filter aid typically depends on the application, availability, and cost. So now let's take a look at the filter leaves. This is an example of a leaf that we have in our Auto-Jet filter. So as you see, the filter leaves have a mesh surface on top that allows for the filter aid to build up, forming a nice even layer of Precoat on top of them. We have different types and materials of the leaves. We have the metallic laser welded leaves, or we have the single U with a cloth outer layer or a metal outer screen. And for very corrosive applications, we also have non-metallic FRP leaves that can be used. And we have different designs for the leaves as well. We have the circular center discharge, which is what is shown here. We have the circular bottom tube discharge. Often this is used for like dry cake applications. Or we have the rectangular bottom discharge, and this is typically used in our Filtra-Matic filters. It's important to note that if operated correctly, these leaves have a long lifespan. They're durable, and one of the advantages is that if they are damaged, they can be repaired, which will lower your operational expenses during the lifetime of operation. Now we'll look through some of the advantages of using Precoat filters. So Precoat filters can remove particles that are 0.5 to about 1 micron. We saw that earlier. And this provides a fine filtration and also reduces the solids down to less than 1 ppm. Typically, Precoat filters can be fully automated, and this goes from the Precoat cycle to the filtration cycle, the cleaning cycle, and then back into service with the Precoat cycle. Another advantage we have is because the leaves have a Precoat layer on them, the internal elements are protected from fouling, and this can lengthen your keep the integrity of the leaves. And also, we add there's an ability to add body feed to your application. So if you do need to get a longer runtime, Precoat filters with the addition of body feed, you can achieve that. And with all of this, you can see how the Precoat filters can handle a wide range of applications and different types of solids that would otherwise quickly blind other filters. Continuing on with the advantages, when you compare to a bag or a cartridge filter, Precoat filters are usually a good alternative when it comes to removing large amounts of solids and also maintaining like a longer filtration cycle. These are relatively low in capital cost and also are durable and robust. We have many filters that are still in operation after 30 plus years. These filters can also be made of all different kinds of materials. We have coated carbon steel, stainless steel, and high alloy, and this goes for both the vessel and for all the internal parts. Another advantage of Precoat filters is that they can take in applications with a wide range of pressure, temperature, and pH, and is typically only limited by the availability of the material. If there is a need for CIP due to fouling or any other reason, this can be performed by adding a temporary CIP tank, pump, and valve. So next, we'll look at the different types of Precoat filters we have and how each of them work. So we have three main types of Precoat filters. The first one is the Auto-Jet or the rotating leaf filter. We have the Filtra-Matic, which has the fixed leaf filter. And we have the Auto-Shock or the candle filter. For today's presentation, we're going to focus on the Auto-Jet and the Filtra-Matic filters. So first one is the Auto-Jet or the rotating leaf filter. This is a horizontal filter with leaves that are arranged vertically throughout the length of the filter. Again, this can be fully automated and can be designed for either wet cake or dry cake discharge. These filters have a door that once you open it, you have an easy access to each of the filter leaves for either inspection or maintenance. Auto-Jet filters typically come with three types of doors. We have the auto-lock door, swing bolted, or the roto-lock door. Both the auto-lock and roto-lock have the quick opening feature. Now, one of the main advantages that we have with the Auto-Jet leaves is that the leaves have a centered discharge, like you see here. So during filtration, the vessel is completely filled, and the circular design of the leaf allows for flow to distribute evenly through the leaves, as the outer edges are all equally spaced from the center of the leaf. So this allows for an even distribution of Precoat and also for the solids to build up. Also, the Auto-Jet has a fixed spray header with slew spray nozzles for cleaning each side of the leaf. So during the cleaning cycle, the leaf rotates while the spray nozzles clean both of the leaf surfaces. This usually gives you a fast and efficient cleaning, and the cleaning is typically based on either differential pressure across the filter, or it can be set for a specific cycle time, like every 18 or 24 hours. And it should be noted that the cycle time should be carefully selected to make sure there's no cake bridging between the leaves, and if so, the cycle time should be adjusted accordingly. So we have two configurations for the vessel of the Auto-Jet. We have the single conic or the double conic design. So for the single conic, you can see that it's sloped on one side. This allows for the cake that falls to the bottom to be washed out from the drain on the end. On the double conic, we have the slope on both ends. So when it falls to the floor, it is taken out through the drain in the middle. And choosing between the two is dependent on the flow rate and also the filtration area that is needed for the application. We also have the wet cake discharge type or the dry cake discharge. So depending on the need for the client, you can use water to remove the cake from the leaves, which then falls to the bottom and is taken out through the drain nozzle. Or we can provide it with an air inlet nozzle that can be used to dry the cake and take out any moisture. And the dry cake then falls to the bottom of the vessel and is removed using augers at the bottom. So now let's take a look at the Auto-Jet sequence, and we'll do it through a video. So this is our typical Auto-Jet filter. We have the Precoat inlet and Precoat outlet, the service inlets and service outlet. And if you see here, this is sloped on both sides. So this is the double conic that we looked at. We have a pressure safety valve and a vent valve. And we have a sluice at the top that we looked at, and we also have sluices at the bottom to wash out any cake that is at the bottom. And the motor is used for rotating the leaves. And that's the drain in the middle that we looked at earlier. This is the auto-lock door type that can be opened quickly, and each of the leaves can be taken out for inspection or maintenance. So this is the internals. You can see the leaves are arranged vertically. You can see the fixed spray header on top and the spray jet nozzles. So this is one of the leaves. This is the center discharge leaf. This can be made of different materials as needed for the application. Now we'll take a look at a full sequence of the filter, how it operates. So the first step is the Precoat cycle. So for this, the vessel is filled with the Precoat solution and is recirculated until you get a nice thin layer of Precoat on each of the leaves. And once that is done, you can start the service cycle, and you can see that the solids build up evenly on all the leaf surfaces. And depending on how it's set up, either with differential pressure across the filter or a service cycle time, once the service cycle is completed, you'll go into the cleaning cycle. And for that, the first step is to drain the vessel, and then you start your cleaning. So you can see that the leaves are rotating and the spray jet nozzles clean as the leaves rotate. And once the cleaning is done, the filter can be placed right back into the Precoat cycle and back into the service cycle. Now let's take a look at the second type of Precoat filter, which is the Filtra-Matic. This is where the leaves are not rotating, they're fixed leaves. Again, this is a horizontal tank with vertical leaves. The sluice spray header in this rotates to clean the filters. If the Filtra-Matic is designed for a dry cake design, we can also provide a fixed vibrator to remove the cake from the leaves. Typically, these are fitted with a breech lock door design that have a quick opening feature. These also have a manual or fully automated retractable tank or the leaf bundle. We'll look at this configuration in another slide. The ability to open the leaves out altogether gives you easy access to the filter leaves for inspection and maintenance of the leaves. Another advantage you have with the Filtra-Matic is that you have a larger flow capacity in comparison to the other ones. So this is another view of the Filtra-Matic. You can see in this configuration, you have the shell of the filter in the retracted position. And this can be either automatic or manual. and each of the leaves have a spray header oscillator that goes around to clean the leaves. This is the inlet header. Sometimes you can have cake scraper to remove the cake out of the leaves. You have the sluice inlet and also the influent and effluent headers. This is the two types that we looked at. It can be a retractable bundle, or it can be a retractable tank. The retractable bundle is where the leaf bundle is moved out, and typically this is used for dry cake discharge, and or you can have the shell of the vessel come out, and that is typically used for wet cake discharge. One of the concerns that clients usually have is what to do with the sludge or cake that is removed from the Precoat filters. And the sludge options typically depend on the location of where the plant is, as well as the composition of the solids that were removed from the filters. These are some of the options that you can have for the sludge disposal. For recycling, spent sludge from various fermentation processes with no toxic contaminants can be a good medium for microbial culture and can also help with the nitrogen carbon balance in the soil. Spent DE and clay mixture can also be used to make clay ceramic bricks. The DE added to the clay mixture reduces the density and typically provides a good insulating characteristics. Now for the energy recovery options, both spent DE with oil and also dried cellulose can be used as supplementary fuel like for furnaces. Also, sludge produced with biomass from like food and beverage industries can be sent to anaerobic digesters to produce biogas. Now, if you are sending the sludge for disposal or to the landfill, one advantage you have with sludge that has DE is DE can help dewater the sludge and reduce the volume and weight of the sludge before it is sent to landfill. And also, depending on each of the client's needs, we can look at identifying, ways of reusing the sludge based on the geographical, location and also the sludge characteristics. So now we'll look at some of the capabilities. Precoat filters that Veolia can offer are standardized products, but we also have the ability to easily customize them for each of the applications. We also have various vessel styles and materials that we can make the Precoat filters out of. Currently, we have about 1,554 Precoat filters installed, and majority of them, as you see, are the Auto-Jet filters at 1,096. And we have 240 Filtra-Matics, 139 Auto-Shock, and 79 Vertijet. The Vertijet filters are no longer in production. Now, for the Precoat filters, depending on the requirements of the client, we can provide just the vessel only, like the vessel with the leaves and the motor and the internals, or we can provide like a skid package with the face piping, instrumentation, valves, controls, etc. We can also do a full mechanical and electrical testing of the complete skid. This is a project we did recently where we provided the vessel, the piping, we provided the Precoat and body feed tank, Precoat and body feed pumps, and you can also see we provided the handling equipment for the Precoat body feed. And keep in mind, this can be either automatic handling systems or manual handling systems. So we have the ability to do a full skid package of the entire system. Since we have a large number of installations all over the world, we also provide an extensive spare parts and field support services. And we have like 7 dedicated aftermarket staff that help with the startup and ongoing field support issues. We have an established supply chain for all the filter parts, and we even have a lot of these parts stocked at our warehouse to be able to provide a quick turnaround for any spares that are needed during operation. And because of this, we also have competitive pricing on all the spares. We also have services for on-site visits, process optimization, and also virtual and on-site training. Ultimately, our goal is to minimize production interruptions and downtime. So now let's look at some Precoat filter applications. So we have Precoat filters installed in all of these industries, like for the mining industry, like the gold and silver mining, soda ash, for the food and beverage industries like beer, wine, whiskey, phosphoric acid, juice processing, liquid sugar, pig hide gelatin, also vegetable oil. Also for chemical processing industries like the amine processing and catalyst removal. And for new applications, we have pilot test units that we have available, so we can test the effectiveness of Precoat filters for these fluids. We can also, test various flux rates to determine like the right vessel sizing, and we can also test performance of the filters prior to doing a full-scale system design. Recently, we did pilot testing for a reuse application to remove carbon fines from a filter press filtrate. We also did another pilot testing to remove radium from produced water. Now we'll look at some specific applications and case studies. This is a schematic for a Merrill-Crowe process used for gold and silver processing. As you see here, the process starts with crushing and milling the gold and silver ore, and then it's allowed to dissolve or leach into a cyanide solution. And after that leaches into it, it is decanted and sent to the Precoat filters to separate the dissolved gold and silver cyanide solution from any of the ore particles. The Precoat filters that are installed here typically remove the suspended ore particles to below 1 ppm. I also want to point out that the next step in the process is to remove any dissolved oxygen in the solution, and we provide vacuum deaerators as well. And the vacuum deaerator typically removes dissolved oxygen down to 5 ppb. This shows the typical process characteristics of a gold-rich cyanide solution that is sent to the Precoat filters. The solids loading typically is between 50 to 500 ppm. Typically, these are made of carbon steel, like the vessel outside, with 316 internals for the leaves and everything. We've provided both Auto-Jet and Filtra-Matic filters for the Merrill-Crowe process. And we've provided both just filter or a fully automated system, including the body feed and Precoat systems. And we've also provided the Precoat filters along with the vacuum tower and the vacuum pump skid for oxygen removal. This is one of the projects that was done recently for a gold and silver mining plant. They were looking to expand their production capacities, and we provided 7 new Auto-Jet filters. The total flow rate to these filters was 13,750 GPM, and we had 100 ppm coming into the filters. Design temperature was 180 F, and the pH was 11. The clarified effluent that came out of the filters removed suspended particles to below 1 to 3 ppm, and all the particles above 1 micron were removed. Precoat filters are also used in the production of sugar from beet. In this process, the beets are washed and sliced and then sent through a diffuser where hot water washes over the sliced beet, and that process absorbs the beet sugar into the liquid. Then the sugar-rich raw juice is purified by precipitating the non-sugar components in the water before it's concentrated into a sugar syrup. This is where the Precoat filters come into play before the liquid is sent for evaporation and crystallization into beet sugar. This is the typical process characteristics for beet sugar applications. The flow rate and TSS typically varies depending on the application and the client, but the outlet solids usually are less than 1 ppm. We've installed Auto-Jet filters from 600 square feet to 1,400 square feet for these applications, and typically they're all automated systems. We did a project recently where a beet sugar manufacturer wanted to expand their capacity, and they were replacing their older filters. So we provided 5 larger capacity Auto-Jet filters with the interconnecting piping so that it fits into their existing plant layout. For this, the total flow rate was 1920 GPM, and the inlet solids coming in was 100 to 200 ppm. Design temperature was 220 F, and pH was about 8.8. Again, in this one, the filtered sugar syrup had solids coming out at less than 1 ppm. Of all the solids, 1 micron and above were removed. Another case study for the food and beverage was for a phosphoric acid manufacturer. They were looking to replace their original Auto-Jet filter that was installed. So this was a flow rate of 80 GPM. This had really high solids coming in at 0.3 to 0.5% solids. And the design temperature was 194 F, and the pH was about 1 to 2. And the filters that were installed were able to achieve less than 1 ppm solids out of the filter. This is another project that we did for a pectin manufacturer. They were expanding their plant capacity. The total flow rate through this was 90 GPM. Inlet solids coming in was 500 ppm. The temperature was 150 F, and pH was 1 to 2. Again, at the outlet of these filters, we were able to get less than 1 ppm. We've also installed Precoat filters for the soda ash process. This is a typical schematic for the soda ash process. Here, the limestone and coke is heated in a kiln and then bubbled through an ammonium chloride salt solution, which precipitates the sodium bicarbonate or soda ash. The Precoat filters that are used here usually filters the soda ash particles from the ammonium chloride solution. This is process parameters for a typical soda ash process. Flow rate again varies from application to application, but the inlet solids coming in is between 200 to 500 ppm, and the outlet requirements are usually less than 1 ppm. We've installed Auto-Jet filters from 600 to 1500 square feet area, and again, these are typically fully automated systems. This is a project that is ongoing. We had 32 Auto-Jet filters installed for this soda ash producer back in 1962, and they're doing a full plant upgrade. So half of those, so 16 of the carbon steel vessels were replaced with stainless steel, and each of the vessels are about 1,000 square feet Auto-Jet vessels. And once these are commissioned, we're going to replace the rest of the filters as well. These are some of the other applications where Precoat filters are installed. They're installed in the corn wet milling industries, and usually it's to decolorize the corn syrup. It's also installed in the gelatin industries to filter a dilute pig hide gelatin, and also in the brewing industry, mainly for primary and polishing filters, but also to treat water prior to the brewing process. And you can see in all of these, the outlet solids were able to achieve less than 1 ppm, or some of them less than 0.5 ppm. And we have various sizes of Auto-Jets installed in each of these applications. In summary, Precoat filters are able to achieve fine filtration and remove particles above 0.5 to 1 microns, and achieve an effluent quality of less than 1 ppm. Precoat filters have the ability to handle high inlet solids coming in, and can handle a wide range of temperature, pressure, and pH. We saw that we have 3 types of Precoat filters. We saw the Auto-Jet, or the rotating leaf filter, the Filtra-Matic, or the fixed leaf filter, and we also have the candle filters. We have over 1,500 installed filters all around the world, and many of them have been in operation for over 30 years. We can provide on-site and off-site technical and process support, as well as aftermarket support for spares and field services. With that, I'll hand it over to Joe.
Great, thank you so much, Kim. And with that, that'll kick off our Q&A session. We do have a few questions that have come in. And before I do that, I do want to mention that we are recording this webinar as well, so you will receive a copy of the recorded webinar. I believe it'll probably come to you tomorrow as well, so be on the lookout for that. And then I would also like to welcome Oscar Velestegui, with us. He is the technology manager for our Whittier Filtration technology products as well. So with that, I will kick off the Q&A with Kim and Oscar here. Kim, first question that we have coming in is there a way to save the raw liquid instead of draining it during cleaning?
Yeah, we can save the raw liquid that is in the filter. Usually these are recycled back to the feed tank, and typically this can be pushed with the air inlet nozzle that I talked about earlier, and we can also use the bottom tube discharge type of leaves for this to be able to actually achieve removing all the liquids and pushing them back into the feed tank.
Great, thanks. Next question that came in is, how often is chemical cleaning required?
Typically, we don't require chemical cleaning. The Precoat filters, because they have Precoat on the leaves, this prevents them from fouling. But if there is a need for CIP, you can install like a temporary tank and a pump and valves to be able to do the chemical cleaning. But typically, unlike membranes and stuff, these do not need any periodic cleaning.
Okay, next question, looks like that we've got here is, what is the average runtime if TSS is 20 ppm?
If you have a TSS of 20 ppm, the runtime typically depends on a lot of things. It can depend on the application. It can depend on the solids that are coming in the feed. It also depends on if body feed is being used, and also it depends on the flux rate that is used for the filter. But typically, if it's 20 ppm, we'll probably see several days of run length, but we would say send us the details of the feed characteristics, and we can kind of help approximate the run length on it.
Okay, I think we've got time here maybe for a couple more questions here. Talking about specific design criteria, can you speak to how Veolia develops design criteria for a specific Precoat filtration or Precoat filter application?
Oscar, do you want to take this one?
Yeah, sure. So to be able to design the vessel to, I guess, size the vessel, we would need to know, I guess, obviously the total suspended solids that are coming in to our vessel, along with the composition of the liquid, pH and temperature. And with that, we can either do an assessment of something that we have done in the past and provide some preliminary sizing. And what we always encourage people is that if you have the liquid available with the solids and everything, is to do a quick bench scale test, the same one that Kim showed here. And that will be the best tool that you can have to make sure that you determine the proper size and the runtime of this equipment.
Thanks, Oscar. Another question that we've got here is, would it be possible to use granular activated carbon as a filter aid? And if so, are there any applications or installations like that?
The answer for that is yes. People are doing that today, to use that as that. The only difference would be what else is on the matrix of this liquid. If it's only activated carbon, then do you have some solids along with that? We've done a couple of things here. We've done, I guess, pre-coat the vessel and then use the activated carbon after that. Or we can do tests to be able to see if we can use just the activated carbon alone on some of the applications that we have.
Great. Question here about variability in solid speeds. So talking a little bit about that, and then what strategies are used when you do have that variability?
I'm assuming, yeah, go ahead, Oscar.
Okay, we don't have a problem to get variability on solids. So usually people would do what is called a PSD, which is a particle size distribution. And we can, I guess, remove with the Precoat filter anything about 1 micron. So if you have a curve of different particles that fall into the 1 micron and 2 and 5 or something, then is not a problem for us.
Great. I think we've got time. We're running a little bit over, but got time for maybe one more question here, and I apologize if we did not get to all of your questions. If we did not answer your question directly here, we will follow up directly with you. So to round out our webinar here today, let's see, is Precoat filtration used for concentration and or dewatering of waste biosolids from industrial wastewater treatment plants?
I haven't seen many applications on that, but Precoat is used to dewater, I guess, solids on a typical filter press when you can really, I guess, achieve dewatering percentage that you're looking for. People will add, I guess, DE to the feed going to the filter press. So for that reason, you can say that, I guess, a Precoat filter could be used on a similar application.
Great. Thank you both very much. And thank you, Kim, today for that very informative presentation. And I do want to thank all of you who attended as well. We do value your time and appreciate that you took the time out of your day to join us. As a reminder, we are recording this and it will be sent to you tomorrow. In addition to that, we do ask that you please take that quick survey at the end. That does help us. And for that, you will be entered into a chance to win that $25 Amazon gift card. So we will follow up directly with you should you be chosen to win that. And with that, that concludes our webinar today. Please feel free to check out any upcoming and on-demand webinars again over at that www.veoliawatertech.com. And thank you guys very much. Any questions, feel free to follow up directly with us as well. Thank you.